Yeah, recording started, so please start. So Dr. Shiv Shankar Das Mahapatra is one assistant professor at Kulani Government Engineering College, and he is going to start now his presentation. His is the second and last part, but very important application of neural networks using MATLAB. He will demonstrate for the benefit of all concerned. So anybody can try and apply. Please start.
Yes, sir. Just 1 minute. Okay. So very good afternoon to all and to our HOD sir. Thank you to sir for organizing that type of webinar, because of this thing is very important to the researchers who are in say master degree or who are in PhD. They whatever the say area, they if they have some data, if they want to predict or estimate something what can be in future, what can be for that particular data, what will be the output, so they can use that particular thing as a tool, artificial neural network as a tool. So I hope this is very important. And
Make it please full screen.
okay, and the theoretical part already covered by our Professor Santanu Das. Sir, so thank you, sir, again for describing each and everything, whatever will be required regarding that particular tools, whatever the theory will be required. And so now basically I want to discuss how to use and how to implement in our say any say particularly MATLAB, how to use, how to implement ANN if you have some data with you. That part I want to cover in my particular presentation. I'm not going through the theory, just maybe 2 or 3 slides I will cover few fundamental parts, then I will directly go to one practical examples, how to implement that ANN. Okay. So the mail ID and mobile number is mentioned here. Again, end of my presentation, again I will show. If you are interested, you can contact with me directly, or you can contact with our HOD sir. He can forward to me. Okay. So now comes to the what are the presentation contents. The basic idea of ANN, just I told you I will take 2 or 3 slides. Then directly I will go to one real-time example. What are the real-time examples which can inspire to think about the implementation of the ANN. Whatever our sir has till now discussed, the theoretical part and implementation level with the mathematics, what they have done in their time. But we are very lucky that now that we can use as a tool. With a sir also told that in a single day we can have lots of data. If we have data, we have lots of results also. So that will helpful for publication purpose. So a few real-time examples I will show you, and one experimental investigation and implementation of the ANN. So now comes to the neural network, few basic parts. This is basically comes from the biological neurons concept, what we have in our brain basically. That is the just like a mimics, just like a replica of our what are the biological neurons are there. Say there we have to, when you have to code, when you have to program, when you have to think about that ANN, we have few idea regarding that what is exactly the biological neurons are there. That figures also has mentioned in our previous speaker also told. Here I have given some figures how to relate that neurons to our neural networks. Now comes to why ANN, why artificial neural network. Now ability to learn, that we know, this is the one sentence regarding the machine learning, and it will require the previous knowledge. If you have some previous data, if you have some previous knowledge, you can predict, you can estimate, you can forecast that whether that COVID-19 situation will comes within 6 months. At least you can predict that what are the situation now coming the last few days, so that you can predict that whether in the next 6 months it can be possible. So you should have some previous knowledge, you should have some previous data. With that lots of data, you can predict, you can estimate at least as a few knowledge. Suppose your flight is tomorrow, you have to go to Delhi. So what should be the what things you have to carry? What is the weathers in the last few days? So you have to predict. You should have some previous knowledge. So this is basically the few fundamental things what we deal with in our daily life. But when we have to use that artificial neural networks in our research work, we think that it is somehow different. That is, I think that is not like this thing. Every day we predict something, that how much amount I have to spend in next month so that I can save that much amount. That will comes from our previous knowledge. This is also one application of your estimation, that is your some neural network, that is one application. Now it has some limitations. Limitation means in case of our biological neural networks, it has billions of brains, billions of neurons are there. But if you have to design in your system, in your PC, with some say hundreds number of neurons, 100 number of nodes, then your system has to be so much sophisticated that will be Core i7, Core i9, or maybe that too much, because that is a complicated thing. So this is the limitation with respect to our biological neurons, what we have in our brains. So this is one very fundamental limitation. Now comes to very basic history, that all of you have that idea. I just here I have mentioned, you can see this thing. I'm not going through that part. Now this thing, I hope I have already discussed that this will comes from our brain. Again, I'm not going through this slide. Now comes to this thing, that particular figure already mentioned by our Professor Das sir, that there is the biological neurons, what exactly has. Now it has one nucleus, a dendrite, then axon, then it will passes that message to the next biological neurons. So these are the very fundamental parts of the biological neurons. You have to know this part, because of once you have to design, you have to do with the words, you have to deal with ANN, you should have that idea. What are the basic parts in our biological neurons? So that's why I have given here. So few red color parts, if you see, that is exactly that will be required when you have to design. What the terms have been mentioned by HOD sir, that weights, that bias, that terms are exactly related to the red color. If you see here, some inputs have excitatory effects on the axon, while others have inhibitory effects. Some activated, inhibited, that is related to the weightage bias. So bias terms already mentioned our sir, and weightage also. Weightage means, suppose if I give one very simple example, suppose now the webinar session is there, maybe the other fellow he has to engage with some other classes. So on which is the most important to you, whether you have to attend that webinar or you have to attend that class. So that is the weightage, basically how much weightage you are giving, whether you will attend the that webinar by SDM sir or by SD sir. Maybe that you will giving 80% weightage of that webinar, you are giving 20% weightage of that particular class. So your functions which will be activated in your brain, that you should have, you have to attend that webinar because you have given 80% weightage. This is one very practical example. And what is bias? If I say bias means whether that 0 or 1 like of this thing. Say Suppose if I say in terms of our mechanical point of view, suppose some spool valve, some valve, whether it will opens, suppose it will opens after giving the excitation voltage, after 1 voltage, it will starts to open. So this is the bias voltage. After 1 voltage, it will starts to work. Before 1 voltage, that is basically not working. That you can say as a binary term 0. So whether your neurons will start to work, yes or no, this is the biasing term, 0 or 1. So this is the fundamental parts. Now the components of the ANN already I have mentioned. Now comes to here. This is one important. This is one important part. What I have told, I just try to relate, and already this part has mentioned. Again, I am saying, suppose whatever you have the inputs and you have some weightage, that summation part already mentioned by your Professor Das. So you can see here. So this is the relationship between input, weightage, bias, and output. And so what can ANN do? Now it can have some ability to learn, and some depends on the weightage, depends on the biasing. It will start to predict. It will start to some prediction purpose or some estimation purpose also. So this is the feed forward ANN structure. Sir also mentioned what are the inputs, what are the layers, what are the hidden layers. So here also that things already mentioned. I hope this figure already sir has mentioned there. So it need not to discuss here. Input layer, hidden layer, output layer. Some question has come that, sir, whether we'll take 1 layer, 2 layer, how many neurons that should be in hidden layer. So how we can change this thing? Maybe that question will comes after my slides. That maybe that has sir told that will comes from trial error method. There basically depends on the user how they will take the data, the previous data, how much it is closer to the actual value depends on this thing, that hidden layer number, that neuron numbers, that will be depending. And one more thing I can say very easily before starting my parts here, depending on the hidden layer and number of neurons, very one practical example. Suppose in my college, I have to solve one problem, whatever I have with me, that I have to go to one, say, Jadavpur University for PhD work. I need one on duty. So if I can solve this problem with my HOD sir, why I will go to principal sir? That if HOD sir has told that, okay, Shivshankar, you can go with my signature, because now today I am in charge of the principal sir. So that is basically in one single layer I can solve this problem. Why I'll go to the second layer? Because that will be complicated. I have to go to principal sir. I have to take the permission whether I can go inside of this room, because he is busy with some other work. So depending on the situation, that will depends how much layer you have to design, how much notes you have to given in your particular layer. Very simple example I have given. From my practical view, I think like this thing. Okay. Now comes to my parts. Directly I comes to my parts. Some few real-time examples which can inspire to think to me also, and it may be to think to you also about the implementation of that particular tools, particular theory, that what sir has told very elaborately. In that present situation that we have to battle with that COVID-19 situation, that here also one applications of the ANN, you can predict, you can estimate. And some of my students, BTech and MTech students, they are now doing the works on that prediction purpose. In one third year student, in the last year, he has predicted the data with the West Bengal, in particular in the West Bengal, what they have started to create the bulletin. With that bulletin, he has started that prediction for the next 15 days. And maybe after my slide, I can show that data. And whatever the prediction has come, that was 80 to 85% that correction that was near to that bulletin after 15 days, whatever the estimations with the actual data, that was very near to that data was there. But maybe you can ask, sir, why it is not 100%? Because there are so many datas will be required and so many functions has to be given. What we don't have that knowledge. But then I have seen one paper which has comes from the statistics one institute. They have predicted one data that was very near to the 95% because they have input so many functions as they have that knowledge. But anyhow, that is the one application field. Another field in your prediction in India GDP that you can apply in the stock market. If you see, if you are related with the stock market in the last day, the stock market has suddenly dropped down because of the next COVID-19 situation has coming. So that's why that in Africa that has come. So suddenly the stock market has already down. So this is one prediction, whether in which company you will invest in the stock market. You have to predict for the last few days data. So this is one application. Now comes to as an mechanical engineer and the department of mechanical engineering department, we have arranged this webinar. We should concentrate on real-time experimental problem in respect of the mechanical engineering department. I have given here one real-time example, but basically that real-time investigation on the abrasive jet machining of some aluminium plates using silicon carbide abrasive. So that experimental not done by me, that was done by one research scholar, PhD research scholar of under Professor Shantanu Das, and he has taken few data and he has asked me in the last year that is there any situation maybe that we can validate, we can test, we can estimate with that particular data set. Then I have started the ANN. Very frankly speaking, in my research work, never I used that ANN. I didn't have any idea. But suddenly that situation has came, and basically necessity is the key of invention. So that is one example. In the last year, I feel. Then suddenly I asked to my research guide there in Jadavpur University, Professor Soikot Mukherjee. He has given one lecture on the ANN fundamental parts. With our department, he has given that lecture as a webinar. Then I have started that ANN, how to solve that problem 1 and problem 2, what was given by that research scholar and our Professor Das also, thanks to them. That problem 1 was mentioned, validation of a set of input data with help of remaining sets of data. Suppose they have the 16 set of data they have taken, then when I will apply the ANN, I have to prove that after applying the ANN, I have to validate whether it will be very closer to that data, yes or no. Second problem was given by them, finding out the possible set of input for which the output will be optimum. I will come, what are the inputs, what are the outputs. Basically, I have given here, maybe in your situation, in your problem, the different input, different output will be there. Different problems can be there. Here, problem 1 and problem 2 have been given. Maybe in your situation, different problems will be coming. So now comes to that problem. The problem which comes from that experimental view. I hope that is very that you can see, but labeling not maybe that is not visible to you. Maybe he has given in that things in a one paper, so that's why that's due to the space crunching. He has given very short figure. But anyhow, this is the one abrasive jet machining setup which is available in our mechanical engineering department, and the main focus what I am going to say here, what are the inputs and what are the outputs here, and how to deal with that inputs and outputs. That means if I have some data of with respect to some input and output, then how we can predict of that. If you say sir, with that particular input, what should be the expected output? How we can find out this value? This is the problem one, what I have shown here. And the problem two is with which combination of the input value so that output will be optimum. Optimum means not necessary maximum, not necessary minimum. It may be depends on your requirements, whatever the situations will coming, it may be maximum or minimum. Now comes to that particular experiment, what are the inputs they have taken? Maybe you can say that, sir, you can take another inputs, that's fine. But for their problem, what they have taken the input they have taken, first thing, SOD, that is stand of distance. Stand of distance. What is stand of distance? Just I try to clear with one figure. I have taken this figure from the net. So this is the stand of distance, means from where the jet, from the just end of the nozzle, from where the jet has started, and that from the starting of the jet to the just starting of your workpiece distance. This is the SOD distance. Fine. Second input they have taken, grain size. What is the grain size? If you give here some jet, then automatically what will be the affected value? What is the effect? What is the output? We can expect that there will be some material removal will be there. So when material removal will be there, so that grain size is basically through that your air and abrasive particles, which strikes to the that your workpiece. This is the grain size. Yes, this is the grain size with the red color. If you see, so that grain size, how much grain size is there? With the say that will be in millimeter or say and micromillimeter or millimeter, whatever that's. And third thing, flow rate. With which flow rate? That combination of your air and abrasive particle strike to the workpiece. This is the flow rate. This is very one important terms in respect to our fluid mechanics point of view. So so three things they have taken as input. Again, I am repeating: stand of distance, grain size, Yes. Any problem?
No, please continue. Somebody was making microphone on and I make it muted.
Okay. So grain size, be careful. Grain size which basically strikes to the workpiece. So from there, you can expect when it will strikes to the workpiece, automatically your workpiece, some that removal process will start. So one output it is expected to the audience. If you don't have idea, all of you have the idea, maybe one or few guys maybe coming from the other background. So that's why I am trying to give the idea. Once it will strikes to the workpiece, automatically workpiece will start. There the removal process will start it. So one output is material removal will start it. So what is the material removal rate? This is one output. What is the second output? What they have taken? The nozzle wear rate. What is the nozzle wear rate? Once through the nozzle, that your abrasive particle and the compressed air will passing through the nozzle, automatically after some days, after some times, after some working cycles, that your nozzle will start, that wearing will started. So what is the nozzle wear rate? That is also one output, because that will depends on your grain size. If the grain size will be higher, that will be higher or less, that somehow difference. If the flow rate will be higher or less, how much it will be related. So what is the discussion from that particular slide? Now what are the inputs? The stand of distance, grain size, flow rate, and the output is your nozzle wear rate. That nozzle with which rate it is that wearing is done. Why you have to know? Because depends on that, after how much date, after how much cycles, after how much times you have to replace that nozzle. Maybe the maintenance will be there, replace purpose will be there, depend on situation, which type of nozzle, which material has to be given, that has to be decided. So this is one important part. Second part, what is your objective basically? Because your objective is you have to remove the material. That is main output. If you see, that is the material removal rate. So 2 output, 3 input is there, 3 inputs are there. So if you see here, some tables are there. Already I have discussed the right hand side. Now comes to the left hand side. What are the tables have been mentioned? Now, first thing, with respect to the inputs, what are, that is the range, what are the minimum and maximum value? What are the range of your particular input? What are the range? Suppose, yes, if you ask me, sir, with some practical, with some very basic example, if you ask me, suppose in case of your, say, weather forecasting, what are the, that your inputs, that what is the what are the what is the temperature, what is the, say, your other parameters are there, what is its minimum value, what is the maximum value? In our, say, West Bengal, in Kolani, what is minimum and maximum? You have some idea within, say, last few years. So that is the minimum and maximum value. You should have idea for your input parameter. So they have mentioned the input parameter range, minimum and maximum value, and they have given here mean value. So this is the table, that first table. What is the second table? Second table, that is mentioned for the nozzle wear calculation, because this is one output, what I have told you. Nozzle wear calculations, how it has to be, they have calculated. I hope you have the idea with the table, with how much time, what is the initial and final weight of the nozzle. From there they have find out, and with some, say, 15 set of data they have taken. With that input, what is the output for that one output, nozzle wear rate? I'll comes to the second output in the next slide, because in that slide it was not possible to show. Another thing, it has mentioned pressure. At pressure 4 kg per centimeter square, maybe that pressure can vary, say 6 kg, 8 kg, 2 kg. They have taken that data with particular pressure 4 kg per centimeter square. When it will be 4 kg to 6 kg, data will be with you. You have the inputs, you can consider the inputs 3 to 4, because pressure has been changed. With 4 kg few data, with 6 kg some data. So you have the inputs, that time the 4 inputs will be there. But at that case, all the set of data with that same pressure 4 kg per centimeter square. That's why they have taken the data set in a table at particular pressure. I'll comes to the other pressures also after discussing that particular problem. Now comes to that slide. This is for the second output, but not second. This is the main, basically the main objective, main aim of the output. This is the material removal rate. That also the same thing, initial weight of your workpiece and final weight of the workpiece. From there they have calculated, and if you see the 15 set, the same value basically again it has mentioned. So now comes to that slide. Here I have, from here my part is started basically. Up to this thing, up to that slide, there is no contribution from my side, very frankly speaking. That was by that researchers, that Mr. Ado, yes. And from here my part has started. What I have started, now in a one single table, I have taken all the 15 set of inputs and whatever the final output of MRR and nozzle wear. Now I have started to solve problem 1 and followed by the problem 2. What is the problem 1? They have asked me, sir, you have told that you can predict, you can validate, you can estimate by ANN. At first, can you validate? At first, you start your ANN with, say, 14 set of data, first 14 set of data, and the remaining data, please you don't add in your ANN, and after doing your ANN work, please try to estimate and predict what will be the output. If it will be very close to the output value, then my work is fine. that I can say that, okay, I have done at least few things. That is my first purpose. I have started. Then I'll comes to the problem two. At first comes to problem one, how to solve this thing. So again, I am repeating in a very single sentence. What is the problem one? How to solve this thing? Now, 15 set of data that researchers has given me, and I am trying to predict and that prediction and or maybe say you can say estimation thing with some ANN, and try to find out that estimation data with that 15 set of data, with the 15th number of data, whether it is very close, yes or no. Just one. Hello. Yes. I am in one meeting. You please call after some time. Okay. Okay, sorry. So this is my problem one, and I am trying to solve this problem one. How to solve this thing? When you have to solve that type of problem, maybe in your situation, the problem can be in different way. Whatever the situations will coming, you can use that particular things what I'll try to show you. For that purpose, I have to minimize that page because I have to open my MATLAB because there I have taken few snapshots from the MATLAB, the important steps. I can show you this thing, but that will be like on theoretical words. Now I am trying to show you directly with the implementation of that particular data, what I have with that table in MATLAB, and try to relate with that PPT also. Just 1 second. Yes. So that MATLAB page is visible to all of you. I hope it is visible, right?
Yes, sir.
Okay. So yes, if you have MATLAB in your system, that is fine. If you don't have, you can install in your system. My suggestion that MATLAB different versions are there, 2013, 17, or say now it has come 19 or something like that way. If your PC, if your laptop is say upper version, then you can install that MATLAB 17 or say 19. But doing that type of work, what I have taken that problem and to solve, not necessary the upper version. You can install the MATLAB 13 also. That can be possible. Okay. So because I have seen, you can see MATLAB 2017. So don't hesitate that that need for that particular version. No need. You can have, if you have 13, you can use that particular MATLAB also. If you have MATLAB in your system, then just I comes to from the desktop, because how to, maybe I hope all of you, maximum of us know the idea, but from the desktop you open that MATLAB symbol, then that MATLAB will be opened, and that page will be like this way. Then how to open that your neural network that tool, because sir has told that in their time they don't have that option, they have to write in C program. That was very task, very exhaustive work really, and here we can use as a tool. But you should have the very fundamental knowledge before using any tool. You just like a say electric switch, if I give the electric switch on, then your fan is started to run, that is fine. But at least we have some idea that some say current is going through that wires and that has started. At least as an engineer we have that idea. So before starting the tool, whatever I have told and sir has told you, if you have that idea, you can start this work. So you have to open your NN tool. So what is mentioned in my PPT, if you see the step one, I hope as I have given that as a not full screen, maybe few things can be visible to all of you as very short size, but I try to, yes. So this is the step one, double click on the MATLAB symbol or from your PC or desktop, PC desktop, or whatever your laptop. From desktop you can open by double clicking. That will comes MATLAB command window. Basically what I have shown you, this is the MATLAB command window. If you see here, command window. Now comes to the third step. If I hope few of our audience, they have the vast knowledge, please don't take like this thing that sir has given again what we have the idea. We are trying to give the knowledge to our students who will start the works very from the beginning level. So that's why I have tried to say from the beginning. Then you write NN start. NN means the neural networks. So that's why you write here neural network start. You are going to start here NN start. So that's why you write here NN start and give the enter button from your computer. Then the neural network tool will be opened. Yes, it is coming. In my system it will take some time, depending on the PC. That maybe take less time also. Yes, it is coming. That's good. So neural network tools will be open and you have to start your work with that particular tool. In that tool, whatever the mathematics, whatever the background mathematics with the weightage, bias, input, output, that already have done. That no need to do. Just you have to give the input and you are getting the output by some procedure, by some steps. That is your task actually. And how to handle with that tools, that is our task to show you. Yes, it is coming. Yes. If you will write that NN start and click the enter button, that your NN, that your neural network page will coming. Here so many options. If you see here, pattern recognition, other things are there. But for our purpose, that what sir also told, that basically curve fitting. This is the curve fitting type of things. How much that your estimated value is closer to the actual value. That is your estimation, that prediction. This is the curve fitting basically. So that's why you have to open that your fitting app. So one, you'll click the fitting app, that app will be coming. Basically just like one applications fields, that app will comes, that new your fitting app will comes. If you see here, few sentences are there, you can read this thing. That the main things what I have to mention, what sir has mentioned in the PPT, one of his research scholar has done this thing, that input and output, that we have the idea. Now try to relate with our practical example, what I have told you in my PPT before starting that work. Input means 3 inputs, that stand-up distance, that flow rate, and other thing is the grain size. What are the output? Material removal rate. Second thing is the nozzle wear rate. In between of input and output, there are some hidden layer, and W is the weightage and B is the bias. If you see, if you remember that mathematics, what HOD sir has told again and again, x1, x2, x3 are the input, x1 multiplied by W1 is the weightage. So from there, that mathematics is the background, and this is the block diagram like of things what we can see from the front side. This is the front panel basically. In the back panel, the mathematics are there. Okay. So then you click the next. If you click the next, there the page has coming, get data from workspace. That means you have to give the inputs, you have to give the outputs. What is, sir, inputs and outputs? What you are going to say here? Now, if you comes here, that table, what I have told you, they have given the problem 15 set of data they have given. First, they have told me with 14 set of data, 14 set of input you are taking, and 14 set of corresponding 14 sets of output data you can take for your ANN purpose and try to predict for the last set of data, that is the 15 set. So in that MATLAB, if you try to give the input, there is none, no data is there. So you have to give the data as input and output. Where you have to give? Now comes to the command window code. Here you have to assign the data because this is the workspace. In that workspace in your MATLAB, there is no data still now you didn't give. So you have to assign the data in one variable. Say, let's say you write here A equal to within third bracket and we say semicolon. Within third bracket, you put the data of the input data. Say suppose you write here, these are the input data. These are the input data. So how to give here? Either you can write one by one. Otherwise, I suggest simply copy and paste. Simply you write the data in your Excel sheet. That is very simple. Say suppose if you see here, this is the yes. So from here, if this is for 4 kg of data, it has started the these are the input data. These are the input data. You just copy the data from Excel and you put within the third bracket, Control V. That is the pasting of the data. So once you will paste the data, it will be pasted. It takes some time as few datas are there and my PC are not too much fast. So once you will assign this data, if you want to see the A, what is the A? If you see write A will show that data with what you have assigned. Now, if you comes to the MATLAB, now if you see here the inputs, just one second. Now, if you comes here, already in workspace, you have assigned some data in A. So if you see here, it is coming. Yes. Now it is coming already A. So if you see here, inputs A is 14 cross 3 matrix because 14 set of data and 3 inputs. So it has come. Now what are the target data? Target data means output. Again it has A. So again you have to assign with another variable name B equal to within third bracket and you assign the corresponding output data. Here already the output data I have written for that webinar purpose at very less time. I have taken all the arrangement in a single page and it will take place time. So here you assign that data. Yes, already B has been assigned. Similarly, you can check whether B has assigned that top data, yes or no. 14. So if you now comes to here, if you see A and B both are coming. So you may ask, sir, can we give here B and A? No, you have assigned as input in A variable. So you give here A and here you give as B. So if you see here, targets B is a 14 cross 2 matrix representing that basically 2 sample of 14 elements. Now, very interestingly, the next button is dissolve. You cannot go to the next because there are some warning has come in. What the warnings? Data selections have different number of samples. Select rows orientation. What are the problems are there? Now that is by default, that is the matrix column. That is basically the column wise. So that is the 14 cross 3 and this is the 14 cross 2. So how you can deal with this? That is the mathematics part of things. So if you do as this thing, if you see here, so that will be, now it is fine because that is your 14 samples of 3 elements and 14 samples of 2 elements. That now you can deal with that data because of that your matrix operations can be done because you know that once you have to solve that matrix operation multiplication of like this type of things, you can solve with m cross n and n cross say p. But you cannot do the work with m cross n and p cross n. So that is the problem. So that's why this was the signal that red red signal has come, and the next button was not working. That is very simple. That message will given you, and it will be done. Or otherwise, another way is there. You can transpose the data also from your command window. But my suggestion, whatever it will be giving the message, try to follow this message. That will be the easy. Now comes next. You click the next. What will be coming? So this is the selection of data already has done. Now, if you click the next, let us see what will come in. Yes. If you see here, this page has comes validation and test data. Validation and test data means I have used here 14 samples. Out of 14 samples in your MATLAB, by default, they will take 70% data for training purpose and 15% for validation and 15% for testing purpose. Fine. So what are the testing, what are training and validation, all are mentioned. Very interesting that is mentioned. Training means these are the presented to network during training when you are giving the training purpose. Suppose for our job also, we are in provisional period, in training period. So these are the, in our total duration of the job, say 30 years or say 35 years, depends on the when you are entering in the job. First 2 years for the training purpose. Then some testing, validation, sometimes your boss can test whether you are now fine, yes or no, to promote to the next step. So these are the testing purpose. Some validations also, they will assign some works for the validate whether you can do that work successfully, yes or no. These are the practical example what we have dealt with daily life. This is the same thing here has been done. Training, validation and testing. Now you can ask, sir, can we change that validation and testing data? Yes, that you have the option in your hand. If you see here, as you have the less number of data, very simple, very less number of data in that particular problem, only 14 data. Maybe in your problem, 100,000 number of data can be there. You can change to the 5%. You can change to the 5%. You by default it will be 15%. Now you can ask that, sir, is there any logic whether it will be 5%, 10%, 15%? Maximum that should be in training, and remaining you have to divide in validation and testing purpose, because once the training will be very successfully, the validation and testing will be successful. That is very simple reason. So now comes to next. If you comes to next, there are few fundamental parts. Here I have to give some time. I comes to the lower portion. If you comes here, my cursor where it has showing, I hope now it is in big size. If you see here, 3 inputs, already inputs as mentioned as 3. But when I have started that verse, below of that input box, it has not mentioned, because you didn't give as input. When you have assigned, it will automatically coming as 3. It will be 2 output, MRR and nozzle wear. So for your research work, research publication, directly you can take that snapshot, that particular things. It will be required what our HOD sir has given that slides. I hope they have taken from there, or maybe after that there also one page is there. So this is one important thing. Another thing, if you see here, number of hidden neuron, here at the option, you can change the neuron number in the hidden layer. If you see here, by default, here one hidden layer is there. In MATLAB, by default one hidden layer will be coming, and 10 is there. If you change here, say 20, then it will be changed. If you see here, 20 has come in. Now already that question was arised by some researchers and some fellows. that what are the, how we can change that whether that 10, 20, 50, how much it will be. Sir has told trial and error. Yes, that answer is fine. But when you do that work, if I have told also that whether you will solve your problem with HOD sir or principal sir, it depends on you basically and the situation. Maybe that day your HOD is on a acting principal, or maybe that situation will change. So by default it will be 10. Whatever the by default setup, my suggestion, try to solve at first with that by default option. If you are satisfied with your estimated value, what in my purpose, the 15th set of data, if the client, my client was that research scholar, if he is satisfied, yes sir, with your estimation 90% accuracy has come, I am satisfied. Why I will change that 10 to 15? Why I will bother about this thing? Why I will spend my time? This is the actually from my side, this is my answer basically, as an that tool operator you can say. So now comes to next button. Yes. So this is basically that page was network architecture. In your paper, you can write the network architecture and you can directly, you can take the snapshot from here. So it will be helpful for your research paper writing that. Yes. Yes, it is coming. Say here the creating network that operations is running. Depending on your capacity of the machine, it will take some time or maybe less time, depends on your PC. So creating network, that means that mathematics, what sir has told, that x1 multiplied by w1, all the mathematics have been done in the background. We are not saying, we are not bothered about, but I'll show you the mathematics, what is background of this thing that will be coming after this operations. You can generate the MATLAB script, what the mathematics are there. You can see this thing also. So it will take some time creating network, because that mathematics establishment has been done in the background. Because as you have given the 10 neurons, or by you can think the weightage will be W1 to W10. So your X1, X2, X3. So X1 multiplied by your say W1, X2 multiplied by, so that type of things already have been done in the background. So it takes some time. Yes, now it has come. Now the next slide, it is showing train network. Why that slide has coming? Because already you have given the data input. If you see here, training, validation, testing, samples 10 to 2, because 14 set. Now the training purpose. Once you have to do the training purpose, you have to select who will train. In our case also, if you will join in any say company, then who are the teacher, who are the mentors will train that particular students, that particular fellows. So these are the basically some algorithm should be required for training purpose. Different algorithm, different teacher has different motivation, different lectures they will give. So what are the training functions? What are the training algorithm? In MATLAB, different functions are already inbuilt. What sir has told in their time, they have to establish, but we are very lucky that already it is inbuilt. If you have MATLAB 2013, very carefully I am saying, please listen to me. If you have 2013, only by default it is LM method. Levenberg's Marquardt method is there by default. As it is the upper version, they have established, they have put other functions, say Bison regulation method and SCG method, that is the scaled conjugate gradient method. All mathematics behind of this. If you have the MATLAB 2019 or upper version, maybe the other functions can be there. I don't know, because I don't have that version. Maybe they can add other functions. So here the 3 options are there. 3 masters are there, 3 mentors are there, 3 functions are there. You can choose. Now the questions can come from the audience. Maybe they can ask after my slides, but I know that questions was come in my mind also. That's why I'm saying, which method I'll use? Again, my answer, whatever the by default, please follow this thing. Then you train this thing, whether you are satisfying, yes or no, then you change. In your research paper, you have the option with LM method, with that particular neural nodes, with that particular your what I can say, that hidden layer, I have this result. With that another functions, I have this result. You can compare this by some bar chart, by some say data, by some percentage. Then what sir has told, that LM method with that particular structure, network structure, is the best possible method. So this is the answer from my side. So with that particular LM method, here the already train button is there. If you click the train, the training process will start it. Now click that train. It will take some time. So if you see here, the training network, the training process has started, and after training, few results will coming. And if you see here, MSE, once it is coming, I will just try to explain what are the blank parts in the column of MSE and R. I hope all of you know this part. MSE, mean square error. This is the mathematical term. So, and other thing is the R. This is the regression value. So, sir, yes, that result has started to comes. I'll explain. Just give me 1 minute. Yes. So R, regression value. So R value 1 means it is very closer to your relationship, input output, your mapping, that is very closer. If you see already the results has comes. If you see here, the R for the training 9.9, very close to the 1. So it will be 0 to 1 basically. 0 means it is very far away, 1 means very near. And MAC means mean square error, very near to the term of the error. So it should be very close to the 0, and R should be close to the 1. It is your part. You have to observe in your MATLAB only whether R is very close to the 1 and MAC very close to the 0. Until and unless that will not be coming, you have the option retrain with that function what you have taken for the training, or maybe you can change the function, or you can go to the back, you can change the number of neurons in the hidden layer. So this is, and you can have the other samples, say not 14, you are not satisfied with the 14 set of data, you will go to the lab, you starts to the works with 100 sets of data, because your sir has told that no, with that very less number of samples, that is not possible. You can start this thing and your prediction, your estimations will be very high. So what is the observation point of view from the research scholar and the tool operator? These two values basically, whether these are very close to the 1 of the R and very close to 0 of MAC value. Now what are the other plots has started to comes? Yes, if you see here, 3 neural network, all that things I have mentioned. What are the training process, LM method, and the performance, basically it will depends on the mean square error, and the other few things already comes. And now if you take here, yes, if anyone in bike, please switch off your microphone. Yes.
I'm muted.
Okay. So if you click the performance, there are so many options: performance, training state, error histogram, regression, fit. All 5 possible graphs can be coming. So you can put that in your research paper. But very frankly speaking, you should have the idea. What is the error histogram? What is regression? What is fit? What is performance? Because once you cannot give only the figure, you have to write the observation. why that curve is coming like this thing with the LM method, why it is coming with like this thing with the other SCG method. You should have that idea. Maybe you have the idea, or maybe we can gather the knowledge from the net, or maybe some books also. But no need to draw that graph with the taking the data separately. You can click that button and directly that will coming. That opening performance plot is coming. If you can see the performance plot, that regression plot, whatever it will be coming. And better I will show the regression plot, because I have already concentrated on the value of the R. So that's why I have clicked the regression. Yes, if you see the regression plot for your training, validation, and your testing also, and then overall for the all value. If you see here, whatever the data has been given here, whatever the value here, yes, whatever the numerical value, you can see here that value also mentioned, and the graphical representations are there. You can ask me, sir, what can you explain that graphs, what exactly is there, so we can write in our paper. Yes, that you have the idea also, that basically what is the things. Now your target value, if you see here, your target value, basically this is the fitting of curve. This is the target value, output target value, what you have taken from the output to value 14 set of data. I have copied and paste in the B variable, capital B variable. This is your target. And what are the, so in training 12, most probably 10 data, here validation 2, here your testing data 2. So if you see here, total 4 circles are there. That means 4 circle means, because 2 your target and 2 is the output data. In that case, here if you see 10 multiplied by 2, 20 circles should be there. Then maybe you can ask, sir, only few circles are visible, why are the other circles? Yes, these are also there. These are in the very that what sir has told, y equal to mx plus c. Here actually c is 0, so y equal to mx. So these are very near to the origin point. So this is the relationship between our previous lecture and that lecture, what you can relate this thing. So these are the all things here. So R value has been given, and overall R already they have mentioned, they have calculated that what is the overall R, 0.98, that regression value has come. So with that R, whether you will be satisfied, yes or no. Satisfied, yes or no means, sir, what you are going to say satisfaction level? Satisfaction level, that will depends man to man. That is very, I know that thing. From here, what you can take technically, yes, if you see validation and testing point of view, some deviations are there. Deviation means, if you see here, your curve is y equal to mx, that dotted line, and this color, that fitting, that somehow it has been deviated, and testing also somehow deviated. So you can start the retrain with the same function, LM function, or with some other function. You can change the number of neurons, whatever the possibilities are there. If you say that, so sir, with 14 set of data, I want to try take the optimum value. Then okay, fine, no need to go to the lab. You have the already that set of data. You have the option, number of changing the neurons, number of say your hidden layer, say your functions method. You can change. You can retrain the process. Retrain means whatever here already the data has coming. Whatever you have given the target at first as capital B, that is the target and output. If you ask me, sir, again if you retrain, I'm coming here. If again if you do the retrain, what will be my that output that comes to here? What will be the target data? Then your target data will be changed. Target data will be coming as output, what you are taking after one training. That will comes to here. Again, after your second training, you will be getting again the second training output data for respective training, validation, and output. By this process, you can do 2, 3 n time of retrain. That depends on you basically. Then when you will be satisfied? Yes, my answer will be very straightforward. Then if you see here, it will be very near to this value, but 100% matching, that is not possible. That I hope. Maybe the answer can be, I don't know, that is not possible, because prediction, estimation, 100% not possible. So at least you can change this thing. You can comes that red line very near to that your dash line. So you can retrain this process, you can change this process, you can comes to that point, you can change this number of hidden layer. So these are the options are there. So if I am satisfied with that your regression R value and that curve, that is fine. Then you can click here next. Why we have to click here next? Because you can ask, sir, already we have taken few data. Already we have taken that network architecture. We have clicked that plots data. That is fine. You have this data. But can you tell me whether we can solve the problem one? That whether we can have, that means if I comes here, whatever the inputs I have given here, 14 set of data, and we have given the output, corresponding output. Then we have, the client has asked, sir, after training, again, if you give that input as an input to that program, whether they are giving very near to closest to that value by your ANN, yes or no. That I have to find out this value. Otherwise, how can I solve that my problem one? For that purpose, you have to click next, means you have to proceed to other process. You have to generate the program. What is the background? What sir has done in that time basically. So now comes to the next button. Yes, there are also some options. If you think here, if you comes here, what I have told you, that there are so many options. Train again, adjust network size. That means what I have told you, that increase the network size, hidden layer, or say number of neurons, or maybe import the larger data of set, what I have told previously. That very basically the last year the fellow who has asked me, I have told him that can you give so many data? He has told that very simple answers and excuse that no sir, it is not possible to come to lab because this is the COVID-19 situation. That is fine. Okay, I have to solve with that 14 set of data. If he will provide me larger data set, you can import the larger data set from here. That the options are there. But you can go to the next button, as I am satisfied with that data. Now comes to here. If you see here, so many options are there. First thing, MATLAB function. MATLAB function, then code generation, Simulink diagram. Simulink diagram means if you click this thing, it will be coming as your Simulink diagram. If anybody, I hope few of you have know the Simulink, how to do the Simulink block diagram. That will comes as the that in Simulink or deploy with Simulink coder tools, it will be coming. For our purpose, you have to come to that just 1 minute. Yes, you have to comes to MATLAB matrix only function. If you click this thing, what will be coming? It is showing that generating means, and still now whatever we have done, that means with that network structure, three input, 2 output, 14 set of data, 10 number of neurons in the hidden layer, whatever the functions with that your LM method, only one training process, you have taken that output. So that program in size of some in some coding, it will be coming directly. Then you may ask, sir, should I write this program in my MATLAB as a code? Then why it is required for the that NN tool? That is fine. You can write this thing. But my answer will be, why you'll do this thing? Already the tool is available. So if you write, your program language knowledge will be developed, that is fine. But whatever it will be taking the time, the other fellow will starts to taking the results and he will publish the papers. So this is the competition market, bhai. So that you have to think in your mind. That depends on you. So the code will be generated. So once the code will be generated, there you can see so many things already has been written. That what are, see, if you see here, whatever you have done, that has been written here. Again, another thing, parallelly I will open, I will explain another thing. Just comes to here. If you click the next, if you click the simple script, then your script will be coming. If you see here, x equal to a, t equal to b, your training function is LM method, and the hidden layer neuron size is 10, and your training purpose 70%, 15%, 15%. So you can write very simple program. This is very simple program. You can write in your code and you can run the program. Here you can change directly also, 70 to 80 or say 15 to 10, whatever it is possible, 10 to 100, each and everything possible. Here you can change the train SCG, that is your third functions, what I have shown there. Your then what are the other functions you can write here. Here see LM method, that back propagations are there. So this is the simple script. What is this thing? So you can give in your paperwork also. This is the script, what is background of that program. Now whatever that I have told previously, that your neural network functions has comings here, that coding. From there you have to I have to solve the problem one. Problem one solving means, again I am repeating, that I have to estimate that output of the 15th set by giving that 15th input after training of that particular ANN. For that purpose, I have clicked that that particular point. Again, I am showing that matrix MATLAB, your MATLAB matrix only function. So that will be coming. After that, what you have to do? So lots of things I have shown you. Just try to relate with my PPT also. Just 1 minute, because maybe that PPT can be shared with you, and so that's why I try to relate. Just give me just 1 minute. Yes, just 1 minute. Oh. Actually, MATLAB is running in background, so that's why the machine is slow. So just wait. Yes, I'm trying to maximize this thing. Yes. So just within a few minutes, I will try to relate my PPT. I hope that is visible to all of you. Yes, comes to that slide. Just give me some time, because it takes some time. Yes. Yes. So if you see here, the steps I try to relate: NN start, then all things that fitting app, then you will come to the neural network fitting. From here, the none will coming, as previously I have told you. Then again, after assigning the A variable and B variable, how to assign, I have already shown. Then A and B you can assign as a variable. So another thing, what I have done in my work, I have done the matrix rows. You can do with matrix column also by some another variable's name, say input underscore 4kg equal to your transpose of the A, and output underscore 4kg equal to transpose of B. Then if you do with column matrix operation, that will be fine also. That will not be a problem. So if you see that PPT, don't hesitate. Sir has told that AB with matrix rows, and here matrix column has selected, don't hesitate. I have taken there, if you see here, the most probably in PPT I have shown the, yes, I have shown this thing. Just 1 minute. Yes, if you see here, yes, IP underscore 4 kg equal to transpose A, OP underscore 4 kg. IP means input, OP means output, underscore 4 kg means this is for the pressure, with which pressure that operation has done, because they have given the data with the 6 kg also. So that transpose, if you do the transpose, you can do the work with matrix also. So don't hesitate. Now comes to the next slide. I hope that also mentioned in my lectures, and this is that slide also came there, MAC and R value. Here you can in training, after training that you can comes to the step 6, evaluate networks. Then comes to here, that plot I have shown you. If you see here, once I have done this work, your testing purpose, that was the deviation has coming. If you see here, 1 and 2 circles are there. Basically, that times I have taken for the validation and testing only one data. That's why 2 circles for one target and one output. So, that deviations was coming. Now that after that matrix, MATLAB matrix, if you click, now that code has coming. Now comes to that once code has coming, you have to save that code. Up to this step already I have mentioned. Why I have shown this thing, just try to relate that part. Okay, now comes to here, you have to save, because this is the untitled. With untitled things you cannot do anything. You have to comes to the save option. So if you have comes to the save button, yes, I hope this is you can save this thing. Yes, just 1 minute, it is coming. You have to save this untitled program. Why you have to save? Because you should have the idea why I have to do each and everything. Because if you save one time, you can predict, you can estimate with any set of input, with any value of the input, what should be the output with that particular program. So you have to save. Where you have to save? Now you go to the documents, then go to MATLAB, then here you can save. You can save with your some conventional some names, say my net underscore some 4 kg underscore. Why I have given this thing now for 4 kg? Because name is very important, because once there are so many programs will be coming, how you can distinguish whether it is for 4 kg, 6 kg or which kg. 4 kg underscore 14 set, because maybe you can give the result with not 14 set, whether when it will be 12 set, what will be the value. So you write this thing 14 set underscore, say today date is say 27/11. You can ask me, sir, yes, you can give here 27/11 or underscore 11, whatever it will be, that depends on you. Now click the save. Yes, just wait, it will be saved as this name. Yes, if you see here, your program name is already changed, mynet underscore 4 kg underscore whatever you have given. Now what you can do with that particular name, whatever we have done still now. Yes, now comes to the command window button. What you have to do now, try to relate this thing. Yes, this thing already mentioned. Now there is another thing what I should mention. With that particular code you can run this program. So that is basically again the retrain. No need to go to your MATLAB NN tool. No need to give the again that A, B. With that particular network structure, you can run this code. That will be retrain process will be there. Okay, so that's why I have shown here, run that program. And now comes to the next slide. Then try to relate. Yes, if you if go to the MATLAB, then I'll try to this thing. So now comes to what is my purpose. What is your purpose or in your field? Now you have to find out, say, if that your let's say if you comes to that program, just again you go to that program. That program means yes. If you go to that, yes, if you see here, and if you see that program, I think this program was, where is that program? Yes. So if you see here, that program X and Y, some terms are there, and another things has mentioned X equal to IP underscore 4 kg. What is this thing? What is X? Sir, why suddenly the X has coming? Now comes to the program. Directly in our program also, what it has coming. If you see here, it has written X, that is the input, and Y, if you go to here, that Q, if you comes to here, I just change the page because try to relate this thing. X is the input and Q is the that what will gives the output. Basically, if you see the total program, you can follow this thing. See, Q is the samples basically. So what you have to do here in that command window, now you give here X equal to, if you see in my slide, X equal to IP underscore 4 kg, because I have given IP underscore 4 kg equal to transpose of A. That's why I have given this thing. But here you have to give X equal to A. If after training, again, if you try to estimate by giving the 14 set of input, that means whatever the input, whatever that input, that is actual output from your experiment. But after prediction, after ANN training, with giving that input, what is the output? At least you can check this thing. You can ensure how much you are secure with that ANN, whether it is giving very near to that value. So X equal to A. So if X equal to, if you give, sorry. Okay. I hope we have to transpose A. Sorry. Then it will be fine. Yes. Already in that time I have done that transpose initially, so that's why that was no problem, because X maybe that has assigned not as 14 cross 3, that is the 3 cross 14, so that's why you have to assign. So if you assign in X as transpose A, so sir, what is X? Again, I am coming. So basically in your program, X is basically the matrix of the input. So you assign the X, comes to the command window. Then you write here Q equal to, if you see here, Q equal to whatever you have given your program name, and you pass your input value. What is that thing? Q equal to, you write your program name, what you have saved, mynet, exactly whatever you have written, please write here, mynet underscore what I have given, just let me see, mynet underscore 4 kg underscore 14 set. Yes. So right here, mynet underscore 4 kg underscore 14 set underscore 2711. So what you are doing, this, there is basically some knowledge of the programming. You are passing the value of the input. That means whatever here X, you are passing this is the X you are passing to that program. Then what will be the Q? That means what will be the output. So see, try to relate this thing. If you now if you click the enter button, then I hope that transpose you have to do most probably. Initially, as I didn't do the transpose of the B, so that's why there's some problem has coming. So yes, so initially my suggestion, initially please do the transpose of the B and A also. Then if you click the enter button, it will give the result as whatever the value with your X, what is the expected and estimation value of the Q. But at that time it is not coming because of the problem. The problem is very interesting things. If the problem will comes in your program, then you can learn at least few things, because the problem is here that matrix operations are there. Whatever the functions in editor, that is say in case of your Q column, that will be, that is the basically 2 cross 14, but we have given here 14 cross 2 matrix, or that type of problem has come. So my suggestion, what you have to do, what the problem I have faced just now, that's why I have did that time. Initially you do the transpose operation. I can show you what I have done in that slide. Just 1 minute. Yes. Yes, you do initially before giving here input. This is the step 3, that IP underscore 4 kg equal to transpose A, OP underscore 4 kg equal to transpose B. Then that problem will not be coming. That problem I have faced initially, then I have done this thing. So then if you do that thing, it will be giving the output like this way. So that comes to here. So that will be giving us like this output. Output means what is the value of your that MRR and your nozzle wear. So if you take the data from here, you may ask, sir, can you please again do that operation? Yes, that operation can be done. So it can take some time. Just again, you have to do the operation by your transpose, or let me check just 1 minute. Give me 1 minute. So it will be very fine. IP underscore say 4 kg equal to transpose. So you can learn if anybody is interested. So that, and OP underscore 4 kg equal to transpose B. Yes. So that fine. So that will be that you can do like this thing, and you comes to just, it will take some time. Just give me some time. Yes. So if you see here, IP underscore 4 kg has come, and IP underscore 4 kg also there. So you have to change here this option. Now comes to the next button. Whatever the things I have done, similar way you have to do this thing. Yes, the same operation has been done. You may ask, sir, why you are doing this thing? Because that problem what I have faced in the in that time, that will not be coming. So now training. Yes, it is coming. Just wait. Now I remember what the problem I have faced that time. That problem has come, so that is very fine. Just wait. If your system is very fast, it will take very less time, because only the 14 set of data. Yes, now comes to next. Yes, next. And then again you click that MATLAB matrix code, and you go to the save button, and go to documents and MATLAB, and give just my net underscore 4 kg underscore say 14 set underscore, that's up 27, say 11, another name you can give, and that will be saved. And now comes to here your command window button, and you write here x equal to your IP underscore, if you go here, IP underscore 4 kg, IP underscore 4 kg. So that is fine. Now q equal to what it has given, q equal to whatever your name, that is my net underscore 14 kg sorry 4 kg underscore 14 set underscore 27 that thing, and you pass the value of that x. Now I hope it is coming. So that is very fine. In a real-time webinar, and that problem has coming and problem has solved, that is fine, because at least that type of error can be coming. That is expected. Once error will coming, that means you are doing something. What the problem was coming, I can what I have solved here, matrix operations that your transpose you have to do initially, because in that function, editor function, these are the whatever in way they have arranged, you have to comes to that arrangement. My suggestion, you do the transpose. If you have the data like this thing, you please transpose this thing, otherwise you have to face this problem, and you can solve like this way. So what has coming, like see, the value q is giving us at first, this is one output set and another set like this thing. How to take this data? I have solved like this way. You can do the transpose as another name, say capital C equal to say transpose capital Q. So it will be transposed. So if you see here, it will be transposed. Now you can copy this data. Why I have done this thing? Because that is in that whatever in this way, that row like this, it will be column like this thing. It will be your first output, it will be MRR, and second thing is the nozzle wire. So you take simply copy and go to again where from where you have taken the data. So you paste this data here. Simply it will be pasted in your say Excel sheet. So now you start to compare. So this first set, this is your basically MRR. Second thing, your nozzle wire. Now what I have done, I have taken this data in this side, and I have taken this data in this side, and try to see how much percentage error you can do like this way. What are the percentage error from this value to this value, how much deviation, with some bar chart, with some graph also. You can give that results in your research papers also. So by seeing this thing, we have seen that okay, that is somehow that deviation is not too much. Maybe if you see here, the deviation is high, because if you see here 0.0813, the last value is 0.13. So what you have to do, once that situation has came, you have to again the retrain. First option, retrain. Why I have told retrain? Because no need to go to your block diagram, your NN tool. Directly you have the function. You can have the option to the run button, and your say run button. If you do the run, I can show you. If you click here the run, then again it is the one training has been done basically. Then if you want to see, if you again some problem has come mostly, that can be solved anyhow. So if you run this thing, then again it has been retrained. Then if you give the value, comes to command window, if you give that value, if you pass the value the same IP underscore 4 kg in X, your output will be changed after training. If still it is not satisfied, you have to go to the block diagram. If you go to back, if you change this option, you can change that LM method to say Bison method. So there are so many options are there. So this is the way how to solve that problem one. What was the problem one? Now comes to that problem one, that we have to validate that problem one's few part, not the full part. Basically problem was that run order 15 I have to check. So how to check this run order 15? If you check this thing, mostly again I have to take this thing. Okay, comes here. Yes. So you can save again. Why I have saved this thing? Because already that function already retrained. Again here you save this previous your previous program. So now comes to documents, MATLAB. You write your mynet underscore say 4 kg underscore 14 set underscore 2 7 11 11 another like this thing. So save. Now comes to here command window. Now what is your exactly you have to solve? Now with giving that particular set, whether it is very closer to this value and this value. So how to pass this value? Just like this thing, you write here that x equal to that time IP underscore 4 kg. That means you have passes all the value of the input, but here you have to pass what is the value. If you see here, I have given here, try to relate with my PPT also. You have to pass only the x equal to 203 and your 203 and 1110. What is the syntax is there? You have to pass this value. Now you comes to here. There you have to write x equal to if you go here x equal to, you have to pass which value? Now 203 and 1110. So within third bracket you write here 200 203 203 and 10, right? Mostly 1110 110. So if you pass this value, so this is as the input. Now q equal to, you write your program name mynet underscore say 4 kg underscore 14 set underscore most 2 7 11 11. So what is the that argument that x will passing? So if you click x, so that will be the output. So this is your output. Means if you copy and paste, if you write here and if you try to see this is 0.1199. That means your actual experimental value 0.1251 and you are estimating 0.1199, but not bad. And 0.00227 0.01. So that deviation somehow it has coming. So you can retrain this thing. Now you have comes your answer of the second problem. That is your that how we can comes to the run order 15 by the remaining set 14 set of data. So this is one solution, and another few times I will take to solve the possible set of input for which the output will be optimum.
Shiv Shankar,
Yes, sir.
actually we are already crossing 1 hour.
Yes, sir. That I will show and I will end. Actually, I have taken my chance from most probably 4:30 or somehow. Yes. Okay. Okay.
So it is just 6
Okay.
p.m.
Okay, sir.
and already number of participants are also reducing.
Okay.
Let's see.
Okay, sir. Okay. So another that problem is finding out the possible that which possible set of data the optimum value will be coming. So for that purpose, what we have done that time, we have tried to find out with different set of input what is the outputs are there. That means how to give these inputs. What I have shown you here, just giving here x equal to within the range. That means that value I have told that within the maximum and minimum range of each and every input, we have tried to see what has comes with that ANN, what is the output as coming. And we have seen that with that set of that input data, that MRR, that nozzle wire, that is minimum that nozzle wear is minimum and your metal removal rate, what is exactly our target, that has maximum with set of data. And so this is the possible set of input for that particular set. We have given the answer like this way. Maybe the question can come, sir, I can check with 158 and say not to exactly 1.8, flow rate is 118. That is fine also. Sir, how many trial and error method, how many set of data you can give? For that purpose, again, I am saying you have to, that problem has raised. To solve that problem, we have to go to some optimization technique, because this is not the optimization technique. This is the prediction process, prediction tool. This is the optimization tool that at least, this is the prediction tool that at least you can predict. Once that type of problem has come, with which set of data optimum value will be coming, then optimization problem will comes. Then you have to go to some optimization technique, say genetic algorithm, say artificial bee colony, or say some other process. You have to shift to this thing. That problem has come. So these are the way we have solved these problems. And for the other pressure, they have given the data, the same procedure what I have told just now elaborately, the similar things we have done. And at last, the other thing I can show you another slide. Our HOD sir has asked me that time, you can take another input as a pressure, you can combine the data. So you have the option that 4 number of input, if you see here. So you have the option that at least 28, 30 set of data, 30 set of data you can predict with the so many set of data. Yes, that is fine. With that set of data, we have predicted and we have seen that whatever the prediction of the MRR and nozzle wear, that was fine with compared to the less number of data. So that was the remarkable observations was find out in from that work. And another thing already I have told you, to get the answer with which set of data, we have to shift to the optimization technique. This is the future scope of work was finding out, at least from my point of observation from this work. So thank you to thank you our HOD sir for providing that works. At least I have started this work and I have started few works with my research scholar, and that research scholar Mr. Adog also, please thank you to him for providing the data. And Professor Soikot Mukherjee sir, he is the professor of mechanical engineering department. He has given at first that webinar on that introduction of ANN up that 17th August 2020 with our department also he has given. So thank you to sir. And I acknowledge to Mintu Pal. Now he is doing the MTech, he is the MTech student. He's started already some works. He has communicated one conference paper. I hope it will be accepted. And he has started to write one journal paper also. And I have asked him to come to the college at least from the, not from the next month, maybe from January, after your semester, you start the real-time work and to implement that ANN. Whatever he is doing, he has taken the data from the previous researchers and he's trying to implement the not only ANN, whatever the regression analysis, regression plot, regression equation, whatever the possibility will be there, he has already done. And the paper already ready. I hope he will communicate in the next week to any one journal paper. But that depends on the journal communication, whether it will be accepted, yes or no. Thanks to Dr. Souvik Chatterjee. Last year he was Mr., but now he has already promoted to doctor. He has submitted. He is the fellow from my lab, that Jadavpur University. He has providing the idea how to install the upper version MATLAB 17. He has helped to our students also. So I should acknowledge. The last but not the least, my sincere acknowledgement, special thanks to my family members, to my children, to my wife, my parents, to providing the times to gather that knowledge. Because last year I know for the few days I have to take the idea how to solve these problems, because whatever I have spent here the time in front of you, that is not the time for me to take the idea. The lots of time I have taken, I have given there. So thank you to them. So my research interest on that fluid power control system, mechatronic system, so particularly the real-time control system of some proportional valve, servo valve, and some controller also, advanced controller, sliding mode controller I have done in my research work, some Lyapunov based online adaptation technique. But very frankly speaking, my PhD work has completed just 2 years back. So still now I have not implemented that SMC and Lyapunov based in my research work with my scholars, but I have started the other works, real-time and also kinematic and dynamic modeling of Stuart platform, one MTech student has doing. And also I should write here ANN, but that time last year I was not my research work, so that's why it was not written. I'll write in the next from the next slide. Yes, and few of my research work, few journals, some reputed journal, IEEE ASME transaction on mechatronics, with some say sliding mode controller, some real-time controller also, with some non-linear integral controller with some electro-hydraulic system. That was in Jadavpur. But here I have started with works real-time and as well as some simulation based, because the last few months, few years, at least last 1 year, we have habituated to work with some that type of works from homework as it is started. So to myself also, I have trained by my neural in my brains that I have to start with some other works which is not directly with the real-time works. So these are the few publications, journal, book chapter, these also book chapter publications, and that what I have told you under review of the international conference, ANN modeling to estimate cutting forces. Another papers also there, but I didn't mention here because still now it has not communicated. And so other thing, as a supervisor of master degree thesis, still now the two thesis has been submitted by Saddam Hussain Mullik and R. Parvasau, and 2 students, they are doing the works, Mintu Pal and Souvik Mondal. Mintu Pal is doing very well. And regarding Souvik Mondal, he started, but very little bit, but I hope he will do the work. And PhD supervisor, I have started to work with Mintu Ghosh. He is an assistant professor of in Durgapur one private college. He has started the work, development and control of a low-cost 6 degree of freedom Stuart platform. So these are the research field. So thank you to all the participants for giving your times also for a long time discussion. But I hope it will be helpful to the research scholar, at least who are in beginning, to work with few data, because now the data are available in nets. So you can start the works with your research works. So any suggestion, doubt, any else, you can ask, or you can put a mail to my mail ID, my mobile number, and you have my mail ID and all details in our website also, you can see there. So thank you again to our HOD sirs and to all the participants. That's all from my side. Yes sir.
Okay, thank you, Dr. Shivshankar Das Mahapatra. Any comment or query from anybody? Actually, number of participants are reducing. Now only 13 or 14 persons are there. Any questions?
হ্যালো স্যার,
Yes.
বলছি যে এসডিএমপি স্যার যেটা দেখালেন ওই এএনএন এ, ওখানে যে রিট্রেনের জায়গাটা ছিল ম্যাটল্যাবে, ওখানে স্যার ওই পারফরম্যান্স টেস্ট আর রিগ্রেশন ছাড়াও আরো কতগুলো গ্রাফ ছিল, ওগুলো স্যার একটু বলা যাবে কি?
ওইগুলোর মধ্যে দেখো, very frankly speaking, I have dealt with particularly regression plot. Other plot, whatever the other plots are there, I didn't go through very details. So very frankly that I am not too much expertise on all that graphs, whatever the graphs are there. But if you try to give in your research paper, you click this thing and try to study from net and with some books, because I just concentrate on the regression plot, which is very important things. Okay. Okay. So that is the thing.
স্যার আর একটা লাস্ট কোশ্চেন ছিল, বলছি টেস্টিং আর ভ্যালিডেশন যে দুটো ছিল, ওই দুটোর পার্থক্যটা একটু বলবেন, মানে টেস্টিং আর ভ্যালিডেশনের মধ্যে কি পার্থক্য রয়েছে?
মানে টেস্টিং ভ্যালিডেশন বলতে they have taken few data for the validate, say suppose 2 data for the validation and 2 data for testing. Validation whatever we have done at last, say 15 set of data, whether it is very clear to this data yes or no, that is whether it is validated yes or no. Okay, so testing, the 3 steps are there basically. At first they will train with that, say in our case 10 set of data. After training they are testing with the 2 set of data. After testing they are seeing whether it is validated with that 2 set of data, what in our case. So 3 step by steps are there. Directly it is not coming from the training to validate. After training it will comes to testing, then it will comes to the validation in your program. 3 steps are there.
Basically, validation is also one stage of testing, is it not?
The stage of testing, sir, but this is the final stage before going to the market basically, that whether that will very close to that validate data in your graph. You can see this thing in regression plot.
In fact, whatever program we have used, in my case, long back, there no validation extra thing was there. Training and testing, these 2 stages are there.
স্যার অ্যাকচুয়ালি ওই যে স্যার যেটা দেখালেন এলএম মেথড, যেটা লেডেনবার্গ কি একটা মেথড ছিল, আরেকটা মেথড আছে ওখানে বায়োসিয়ান রেগুলারাইজেশন, ওখানে স্যার ওই ভ্যালিডেশনটা নেই আসলে।
না ওখানে তুমি পাবে না। In that case, in different functions, in your if you go to your Bayesian method, then in your regression plot only 3 plots will be there, not 4 plots will be there. Okay, so depending on the function that will be changing.
আচ্ছা ঠিক আছে।
Because of that function is capable, without validated they have the capability of that function, inbuilt function, that they can give the assurance that your program after training it is fine for the prediction or estimation. Okay,
হ্যাঁ ঠিক আছে।
okay,
I think if there is no other question, we can conclude here. Thanks to Dr. Shiv Shankar Das Mahapatra for nicely demonstrating the MATLAB programming and MATLAB using system, and also before that elaborately discussing about the AJM setup and the experimental part. Thank you, and thank you the audience for participating till now. Now I will request Ohin Banerjee, who are telling me other 2 participants are there. Can you give their names so that I can just take down their name as a participant?
So do you need it right now, or I shall mail you?
Not you can email. If you just tell, I can note it down.
Okay. So the candidates who are present right now. Devjit Mishra.
No, your friends along with you.
Okay. One is Pradeep Kumar Mahato.
Pradeep? A bit louder, please.
Pradeep Kumar Mahato.
Pradeep Kumar Mahato. Achha.
Yes, sir.
And?
He is also a research scholar in the Department of Civil Engineering, sir.
Okay. And another?
And he is pursuing his research in the area of climate change.
No, I don't record. Only the names I request.
Okay. And another one is Shivani Gond.
Spelling?
SHIVANI.
V.
VANI. GOND. Shivani Gond.
Good. Okay.
so he can write
What is the name of the wife of Devjit Mishra?
Kasturi Barik.
Kasturi Barik.
Barik. Yes.
Spelling?
KSTURIBARIK.
Okay. ठीक है. Okay then. Thank you all for joining. I hope you have learned something.
Yes, sir. Definitely.
Okay. And what is she doing, Devjit?
Sir, she is doing PhD in electrical and electronics department. So she is working on that neuroscience, means neurological things.
Okay.
So she used
Under
to
which
do
university?
It's IIT Kharagpur.
Oh, I recall. Okay. Okay, then, thanks to all. So we can leave now. We are already overshooting time. We thought it will be ended by 5, but now it is 6:15.
Yes.
Thank you for your patient hearing. I hope you can learn something and you can apply that also. That is the key thing.
Yes. Thank you, sir.
Okay. Thank you.
Okay,
Thank you,
sir.
sir.